His 77-pound robot just pulled a 3,100-pound car, and it did it alone. No remote control, no pre-programmed path, just pure autonomous strength guided by an AI brain that, for the first time in history, actually understands how the physical world works. This is not a concept video. This is not a leaked prototype. This happened in a Beijing lab last October, and if you haven't heard about it yet, that's exactly the problem. Because what China just unleashed on the world of robotics is the kind of shift that doesn't announce itself with press conferences. It announces itself by making everything we thought we knew about robots completely obsolete. We are standing at the edge of something that most people don't realize has already started. Not the beginning of humanoid robots. That conversation has been going on for decades. What's different right now? What makes this specific moment unlike anything before it is that China just solved the one problem that has stopped every robot from ever truly working in the real world. Not the hardware problem, not the cost problem, the intelligence problem, the deep, stubborn, fundamental problem of physical intuition, that invisible human ability to know instinctively how to catch a glass before it falls, how much force to use when opening a door, how to adjust your footing on gravel without thinking about it. That's the thing robots have never had. Until now. So here is everything you need to know about what just happened, why it changes everything, and what it means for your life, in ways that are going to arrive much sooner than anyone is predicting. Let's start with the brain, because everything that's happening in Chinese robotics right now begins there. The system is called WOW. That stands for World Omniscient World Model, and it was developed by the Beijing Humanoid Robot Innovation Center in collaboration with Peking University and the Hong Kong University of Science and Technology. On the surface, that sounds like another AI research paper that will get 50 citations and disappear into the academic void. But WOW is something categorically different. And to understand why, you have to understand what has been broken about robot intelligence until this point. Every robot that has ever existed, from the earliest factory arms to Boston Dynamics Atlas, operates on a fundamental disconnect from the physical world. These robots don't understand the world. They execute instructions about the world. They are given precise, predefined commands. Move arm 37 degrees. Apply 4.2 newtons of pressure. Turn left in 0.8 seconds. This works brilliantly in controlled environments. It falls apart the second anything unexpected happens. A box shifts on a conveyor belt. A floor is slightly wet. A human walks into the robot's path at an unanticipated angle. The robot either stops, fails, or causes damage because it has no actual model of how the physical world behaves. It has instructions. It does not have understanding. That gap, the gap between instructions and understanding, is what WOW closes. WOW is a 14 billion parameter multimodal generative model built on what researchers are calling the Sophia paradigm. What that means in plain terms is that WOW fuses a large language model with a diffusion transformer and a physics simulation engine into a single unified system. The result is a robot brain that doesn't just process commands. It imagines outcomes, tests them against physical reality, critiques the results, and refines its next action accordingly. Predict, critique, refine. That loop runs continuously, autonomously, in real time. And that is precisely how human physical intuition works. When you reach for a glass of water, you don't consciously calculate the trajectory of your arm. Your brain has run millions of predict, critique, refine cycles since you were an infant, and it has built a deep internal model of how the physical world responds to your actions. You know before you touch the glass how hard to grip. You know before you lift it whether it's full or empty based on how it looks. You have physical intuition. Robots have never had this. WOW gives them the architecture to build it. Here's a concrete example of what that means in practice. Tell a traditional robot to move a cup off a table without spilling it. That robot will execute a scripted motion it was trained on. Change one variable. The cup is heavier than expected. The surface is slightly sticky. The approach angle is 2 degrees off, and the robot spills the cup. Now tell a WOW-powered robot to do the same thing. It will first simulate what happens if it approaches from the left at standard grip, pressure. Its physics-aware critique engine analyzes the outcome and flags that the cup's center of gravity is off. It would tip. The system refines the approach, slightly lower grip, adjusted angle, slower acceleration. It tests that simulation. It passes. The robot executes. The cup moves cleanly. And crucially, the next time WOW encounters a similar cup, it doesn't start from scratch. It has learned. It has genuinely learned, not just been retrained on new data by an engineer. It has autonomously updated its own physical model of how cups behave. The team created a benchmark called WOW Bench to measure this kind of intelligence, one that evaluates perception accuracy, temporal consistency, meaning whether the robot's sense of motion makes sense over time, physical plausibility, meaning whether the imagined outcome would actually happen in real life, and instruction following across complex scenarios. WOW has achieved state-of-the-art results across all 4 categories. It can generate novel viewpoints of objects it has never seen from a new angle. It can simulate trajectory-guided video sequences with accuracy that existing systems cannot match. One robotics researcher at Tsinghua University described it as the missing link between chatbots and true embodied AI. And he's right, because what WOW represents is not a smarter robot. It's the first robot brain that operates on the same fundamental learning loop as a human nervous system. Now here's where this gets strategically important. WOW isn't just a lab experiment sitting on a server somewhere. It is the intelligence layer being built into a generation of physical robots that are entering production right now. And that brings us to the second pillar of what China just unleashed. Because while WOW solves the intelligence problem, a company called Robotics just solved a problem that most people in the West haven't even framed correctly yet. They solved the price problem. And they did it in a way that is going to fundamentally change who gets to participate in the robot revolution. The robot is called Boomy. It costs 9,980 yuan. That is $1,170 US dollars. Let that settle for a moment. A fully functional bipedal autonomously walking humanoid robot for less money than a mid-range iPhone Pro. To appreciate why this is seismic, consider the current landscape. Boston Dynamics Atlas, the most famous humanoid robot in the Western world, costs somewhere between $150,000 and $200,000, depending on configuration. Tesla's Optimus has been in development for years, hasn't shipped to consumers at scale, and isn't priced for homes. Figure AI's robots are targeting industrial customers with enterprise pricing. Every major Western robot company has implicitly decided that humanoid robots are first a technology for corporations, then eventually for wealthy early adopters, then maybe someday for regular people. That timeline is measured in decades. Robotics just collapsed that timeline into a single product launch. Boomy is 94 centimeters tall, weighs 12 kilograms, runs on a 48-volt battery that gives it 1 to 2 hours of operation, and is built for 3 specific use cases: education, home companionship, and STEM learning for children. It responds to voice commands. It has drag-and-drop graphical programming that kids can learn in an afternoon. It dances. It walks with a fluid. Surprisingly, stable gait across uneven surfaces. In early demos, it performed choreographed routines that would have required a 5-figure robot just 2 years ago. It doesn't have fine finger dexterity yet. It can't thread a needle or button a shirt. But its motion stability is exceptional for its price class, and its walking behavior is genuinely impressive. The team behind Boomy is not a corporate spin-off or a government-backed giant. Robotics was founded in September 2023 by graduates of Zhejiang University and Jiaotong University. Their previous robot, the Noatics, N2, sold over 2,500 units, and this is not a metaphor, completed a half marathon. A humanoid robot ran 13.1 miles. That happened. And the same team is now building Boomy for mass consumer adoption, with pre-orders targeting China's Double 11 and Double 12 shopping festivals, which are the country's largest retail events and move hundreds of billions of dollars in product in a matter of hours. What Boomy represents goes far beyond one affordable robot. It represents the moment the humanoid robot market becomes a consumer market rather than an industrial or research market. And when consumer markets activate, the feedback loops are completely different. When 10,000 Boomies are in homes and classrooms, the data those robots generate, every interaction, every correction, every novel physical scenario, feeds back into training systems. The robots get smarter because of the scale of deployment. The deployment scale grows because the robots get smarter. That loop is how smartphones went from a $600 luxury to a $100 device that 2/3 of humanity carries. Boomy may be the first turn of that same flywheel in humanoid robotics. But if WOW is the brain and Boomy is the affordable body, what China just demonstrated with the Unitree G1 is something else entirely. It's a proof of concept that humanoid robots are not just getting smarter and cheaper, they're getting genuinely, practically usably strong, and the implications of that are enormous. The G1 weighs 35 kilograms. It stands 132 centimeters tall. In a demonstration staged by the Beijing Academy of Artificial Intelligence, this robot, this 77-pound machine, pulled a 1,400 kilogram car. That's a 3,100 to 100-pound vehicle being dragged across a surface by a humanoid robot that weighs less than most adult humans. And here's the critical detail that makes this more than a publicity stunt. The G1 maintained full dynamic balance throughout the entire maneuver. It leaned back against the tension of the rope. It adjusted its foot placement in real time as the resistance changed. It counteracted the torque of the pull without falling, without assistance, without a remote operator guiding its movements. The entire demonstration was autonomous. The G1 decided how to pull the car. The G1 decided how to stay upright while doing it. The G1 succeeded. This matters for reasons that go well beyond the spectacle of a small robot moving a large car. What it demonstrates is that Unitree's motion control algorithms have reached a level of physical capability that is genuinely useful in unstructured, real-world environments. A robot that can pull 40 times its own weight while maintaining dynamic balance and adapting to changing force conditions is a robot that can work in disaster zones. It can work in warehouses that weren't designed for automation. It can work on construction sites and mining operations in any environment where raw strength and physical adaptability matter and where traditional robots fail because the environment won't cooperate with their programming. The G1 features over 35 degrees of freedom. That means 35 independent joints and movement axes, giving it a range of motion that approaches human flexibility. Its actuators are high torque, meaning they can generate and sustain significant force. Its onboard AI handles balance, navigation, and environmental response in real time. And its design is modular, meaning components can be swapped without specialized tools. Previous G1 demonstrations already showed it completing backflips, recovering from being shoved by humans, and running at 3.5 meters per second. The carpool was not a proof that this robot exists. It was a proof that this robot works. And Unitree is not alone. To understand the full scale of what China is doing in physical AI, you have to look at the ecosystem rather than individual robots. At last, January's Consumer Electronics Show in Las Vegas, Chinese robotics startups dominated the exhibition floor with AI-enabled hardware in a way that no Western observer had fully anticipated. Humanoid robots from companies most Americans had never heard of were performing tasks and demonstrating capabilities that major U.S. technology companies were still describing as multi-year goals. The demonstrations weren't rough. Prototypes with engineers hovering nearby to catch them when they fell. They were fluid, confident, polished systems that moved through the environment with a purposefulness that felt genuinely different from anything the robot industry had shown before. At China's Spring Festival Gala this past February, the most watched television broadcast in the country, seen by hundreds of millions of people, humanoid robots from 4 different Chinese companies performed live on stage. They danced. They acted in a comedy sketch. They did parkour. They performed martial arts. Not in a controlled lab environment with padding on every surface, but on a stage in real time in front of a national audience. This was not a technology demonstration for investors. This was a cultural moment, a statement to an entire country that humanoid robots are not a future technology. They are a present reality. And the numbers behind all of this are staggering in a way that changes how you have to think about the global competitive landscape. By the end of May 2025, China's investment in robotics and embodied intelligence had already exceeded the entire full year 2024 total. By July, China had invested $3.4 billion in new robotics ventures, 42% more than the United States, and 5 times the investment level of Europe. Chinese firms are projected to manufacture more than 10,000 humanoid robots in 2025 alone, accounting for over half of global output. According to the International Federation of Robotics, China installed 290,000 industrial robots in 2023, more than the rest of the world combined. And now it is redirecting that accumulated industrial expertise, that supply chain, that manufacturing scale, toward human-centered robotics. None of this is accidental. The Chinese government identified embodied AI as a national strategic priority following the shock of DeepSeek's R1 model launch in early 2025, which demonstrated that China's AI capabilities had matured far faster than most Western analysts expected. The March 2025 government work report explicitly listed embodied AI alongside biomanufacturing, quantum technologies, and 6G as core tools for building the industries of the future. China's upcoming 15th five-year plan, which runs from 2026 to 2030, has been recommended to incorporate embodied AI as one of the primary new drivers of economic growth. This is not a startup ecosystem chasing venture capital. This is a nation that has made a strategic decision at the highest levels of government that physical AI is where the next industrial revolution will be won or lost. And it is executing that decision with a speed and scale that the rest of the world is only beginning to comprehend. Cities across China are building dedicated training environments for robots, facilities that replicate retail stores, elderly care facilities, smart homes, and public spaces, designed specifically to generate the standardized data that makes robots better at operating in those environments. The more real-world data these systems ingest, the faster WOW and systems like it can refine their physical intuition models. And the faster those models improve, the more capable the next generation of robots becomes. This is a compounding advantage, and China is currently running it at a scale that no other country is matching. There are real challenges ahead, and it's important to be honest about them. Hand dexterity remains a significant unsolved problem across the entire humanoid robot industry. Most current systems still struggle with fine motor tasks, handling fragile objects, manipulating small components, tasks that require the kind of precise adaptive finger control that humans develop over years of childhood. Battery life is a constraint. Boomy runs for 1 to 2 hours. The G1 needs frequent recharging, and genuinely useful all-day robotic operation remains an engineering challenge. Safety in uncontrolled home environments is an open question. How do you ensure that a robot operating autonomously won't misinterpret a situation in a way that causes harm to a child or an elderly person? And the ethical dimensions of increasingly autonomous physical AI are not fully worked out. When a robot with genuine physical intuition and autonomous decision-making causes an accident, who is liable? The manufacturer? The operator? The AI system itself? These are not hypothetical questions anymore. They are policy questions that the world is going to have to answer in the next 2 to 3 years. But the trajectory of all of these challenges is toward resolution. The pace of that resolution is accelerating faster than anyone's conservative estimate predicted. Analysts who said widespread household adoption of humanoid robots was 15 years away in 2022 were saying 10 years away in 2023 and 5 years away in 2024. The most current estimates now put meaningful consumer presence of affordable humanoid robots at 3 to 5 years away. And that estimate is being revised downward in real time as Boomy and systems like it enter the market. Think about what 3 to 5 years actually means in practical terms. In 3 to 5 years, a robot that costs less than a laptop could be in classrooms teaching children to code through physical interaction, adapting its teaching style in real time based on how each individual child responds. In 3 to 5 years, a humanoid robot with WoW-level physical intuition could be performing elderly care tasks, not replacing human connection, but handling the physically demanding elements of daily assistance that currently require trained caregivers and are in desperately short supply in every aging society on Earth. In 3 to 5 years, warehouse operations that currently rely on expensive custom automation infrastructure could use general-purpose humanoid robots that adapt to the existing layout rather than requiring the entire facility to be rebuilt around the robot's limitations. These aren't futuristic scenarios. They are the explicit near-term targets that Chinese robotics companies are building toward right now. And here is the thing that gets lost in most coverage of this story, the thing that matters most, if you want to understand why this moment is genuinely different from every previous wave of robotics excitement. The difference isn't just capability. The difference is the combination of capability and cost at the same time. Every previous generation of impressive robots was impressive in a lab and priced for institutions. The Atlas was extraordinary, but it cost $200,000. The G1 is extraordinary, and it costs a fraction of that, and it's being mass manufactured. Boomy is affordable enough for households, and it's walking stably and responding to voice commands. WoW gives all of these systems a brain that learns from the physical world rather than just executing scripts. When capability and affordability converge like this, the adoption curve doesn't slope gently upward. It goes vertical. Think about the smartphone. In 2006, if you told someone that within 6 years, the majority of the world's population would carry a pocket-sized computer with more power,